Welcome to SAP2000 demonstration video part 2, and in this video we are going to show you how to generate a model using generalized grids. Use set of units from the unit selection list. Next, use file menu, new model, and choose grid only template. You have two options, Cartesian or cylindrical. Specify the number of grids in X, Y and Z directions. Please take a note that XY plane is horizontal while Z axis is vertically upwards. You can change it later if you need to do that. In some other programs, it is often noticed that you have to first define these modeling components like beams, columns, walls. That means that you have to first create the geometry and then the connectivity. And after doing that, you would be assigning them their properties like material properties, section properties. Well, in SAP2000, drawing of these modeling components and assignment of the properties is done in one and its simple step. So it is logical that we define the material and section properties first. Choose define menu, materials. Press add new material, choose a region, material type, and then use any predefined property. We are defining here one concrete property of N35 grade and steel rebar properties which will be used later in section definition. After that, after defining material properties, again go to define menu, section properties, frame sections, choose add new property, and now you are giving an option to draw so many different kind of sections. Choose concrete, rectangular, and give a meaningful name which reflects the size of the section you are specifying. Choose its material. Then in concrete reinforcement, select the rebar material for longitudinal reinforcement and ties. Choose design method, whether a column or a beam. Choose the number of bars you wish to use in this defined section and choose longitudinal reinforcement bar size. Similarly, choose confinement reinforcement bar size and check this option, reinforcement is to be designed. Press OK. Define one more property, and this time we are defining the property of a beam. As 250 mm by 600 mm. Specify the depth and width. Choose a material, then choose concrete reinforcement and specify the longitudinal bars and bar ties, steel grades. Choose the design type and press OK. We will be defining the area properties to be used for walls and flat slab or flat plates a little later. we are now ready to draw the columns, beams, areas, and to do further work with the analysis and design. So it is our choice how we want to draw the columns or beams. Typically, beams are drawn in elevation as well as in plan view and even in 3D view. And same is the case with columns. Columns are drawn in elevational view or a 3D view. So it is primarily your choice. So we chose XZ view, and now we see one elevation with y coordinate equal to 40 meters. We chose navigational arrows and we come to grid number 1. Next, we can choose draw menu, draw frame cable, this particular command, or we can choose from the vertical left hand side drawing toolbar, the tool button for drawing frames. We click this to invoke the command, choose a section property and click on the grid intersection point first, and then go to the next joint which is defining the extent of this column and click. Now right click the mouse to come out of the drawing mode and restart another drawing operation. Once it is all completed, press escape to come out of the drawing mode. Now we see a column, but we do not see the defined joints. And please take a note that all joints and these column elements were labeled by SAP2000 automatically. We choose set display option and uncheck the invisible joints checkbox and check the box for frame labels and joint labels and choose apply. When we zoom the drawn objects, we find that columns and joints have been labeled exactly in the same sequence as we drew these. Now press OK. So joints are visible. Select the joint at the base level by making a window so that the joint falls within the window itself. And we choose assign menu and then joints and restraints, and restrain all translations and all rotations. Press OK. Now we notice that a column has been drawn and the base joint has been given the boundary conditions. Select the column and use edit menu, replicate, and replicate it at an interval of 8 meters and do it 5 times. Now select all the columns. Next, select all columns and use edit menu, replicate, and this time replicate in Y direction. And press OK. Now see the 3D view. Use rotate button Now we are removing the corner column on the right upper hand corner and 2 columns from the left lower corner and press delete button. We are now ready to draw the beams, but for doing that we must use XY plane as it is the most convenient option to draw these beams. Now we are seeing the topmost level plan at z coordinate equal to 14 meters. Again use draw frame command and this time choose beam type property. Click on the first joint, then next joint, and then next, and the next, and the next, and right click to come out of the current drawing sequence. If you want to come out completely from the drawing board, press escape key. We can also use quick draw frame command and bring the cursor between two grid intersection points and click. And you can see that the beam has been generated. Or we can make a window and beams are drawn with great convenience. Next, we need to draw a floor object. Now please take a note that our objective of drawing the floor is not to do a detailed finite element analysis as done for the case of flat plate or flat slab. We just want to model the floor only for the sake of load transfer to the beams which are supporting the floor. So how we do that? Please see, use draw poly area command and choose the section property as none. Click on the first joint, second joint, third joint, fourth joint, fifth joint, sixth joint, seventh joint, and last joint. And now press enter. And you can see that the area object has been drawn. We can now assign loading on this area object which would be transferred to the supporting beams. However, we also need to tell to the computer program how this particular area object is going to be meshed, and we want the meshing is to be done at the location of beams only. So we select the area and we choose assign menu, area, automatic area mesh, and we choose the option auto mesh area using cookie cut based on straight line objects. It means that the program will mesh this area at the location of beams only. Press OK, and the area object will be meshed at runtime. We select the area object once again and we choose assign menu, area loads. Now we see that there are two options, uniform shell and uniform to frame. Uniform shell command is utilized when we want to apply the loading on a finite element mesh. Since here we are not drawing a finite element mesh in the classical manner, what we want is only the load transfer to frames. So we are choosing the second option, uniform to frame, load distribution two-way in the direction of gravity. Gravity direction works downwards in minus z direction. And we apply loading of 8 kilonewton per square meter on the area object. Next, we use define menu. We define a load pattern with name as live, type as live, and we select the area object once again, and we use assign menu, area loads uniform to frame, and this time choose the load pattern as live and apply a uniform live load of 3 kN per square meter. Now right click on the drawn area and see the assignments made to it. Loads. So loads are exactly the way we wanted. Our next command is to apply the load on the peripheral beams. So we select these beams on the periphery by drawing a window, selecting all the beams we want inside the window where the loads are to be applied. Next, we use assign menu, frame loads, distributed, load pattern dead, direction gravity. We apply a uniform load of 12 kN per running meter. Next, we select all beams in the drawn area, and we would be replicating it by using edit menu, replicate command, and this time we want to replicate it in -z direction, and we choose the number as 3. Now see it in 3D, and we notice that periphery beams have been replicated with assigned loads, as well as the area objects have also been drawn. Next, we need to apply these joint constraints. We believe that you are already familiar with the concept of constraints. Here we are going to use diaphragm constraint. In a very clever manner, we are seeing this three-dimensional view because we want to select all joints except the joints at the base. The constraints are always applied only to active degrees of freedom. We select all joints except the joints at the base, and next we use assign menu, joint, constraints. Now out of all these constraints available, we use diaphragm constraint. We are actually modeling a rigid diaphragm. Now we chose the define diaphragm label and use apply. Now if we right click on this, we find that diaphragm label has been given by the program. Next, what we need to do, we need to assign the wind loads and earthquake loads. For defining wind loads and earthquake loads, we need to first define the load patterns. So we choose define menu, load patterns, and define a pattern name as WX of type wind with autolateral load in accordance with IS-875. Use modify lateral load pattern, and here we can change these wind coefficients or wind exposure parameters or the exposure height or the fact whether the exposure and pressure coefficients are to be computed based on the drawn area objects or based on the extents of the rigid diaphragm. So we are choosing as shown in the highlighted option from the rigid diaphragm. So use exposure and pressure coefficients to tell to the computer program how these wind loads would be computed. If we want to change the leeward or windward coefficient, then we can change it and press OK. Next, use WY and again choose modify lateral load pattern. Only change the leeward coefficient and the wind direction angle. For the case of load pattern named as WX, the wind direction angle was 0 degree, and that means it was in the direction of x-axis. We change it to 90 for y-axis and we press OK. Next, we use again the same load pattern definition dialog box, and we specify a load case named as EQXP of type quake, auto lateral load pattern based on IS-8093, add new load pattern and use modify load pattern. Here we can select many things like the seismic zone factor, the soil type, response reduction factor, lateral load elevation range, the direction in which we want to apply this load, and eccentricity ratio, whether positive or negative, and time period calculation procedure. It could be approximate or program calculated or user defined. We are using user defined and arbitrarily we are assigning 0.5 second time period. Define one more and use modify load pattern and just change two things. The seismic zone factor and time period along with eccentricity ratio. Define one more as EQYP. Choose global Y direction, seismic zone factor, user defined period as 0.5 second, and one more as EQYN, and again use modify lateral load. Change the eccentricity ratio to minus 0.05, seismic zone factor and time period as 0.5 seconds. Now press OK. By this time, program has defined all these parameters as assigned by us. Next, we are going to define the response spectrum function and the response spectrum case. And then we will show you how we can extract the base shears from this model. use define menu, functions, response spectrum. There are several code-based functions available. We use SAP93, press add new function. If we choose seismic zone factor equal to unity, then the acceleration ordinates are exactly same as defined in ICT93 code for 5% damping ratio. When we specify the seismic zone factor, then these ordinate values for accelerations have been multiplied by seismic zone factor specified. However, you must take a note that these acceleration values are normalized. That means that they are unitless. So you will be multiplying these values by acceleration due to gravity to convert it into acceleration units, and that is done in the response spectrum definition case. That's okay. Next, use define menu, load cases, choose response spectrum as the load case type and assign it a name as spec X. You can choose a specific modal combination or directional combination if you want that. And you can also select which modes are to be used. It is possible in SAP2000 to do multiple modal analysis. So you can choose a specific results from a particular modal analysis to be used for the purpose of doing the response spectrum analysis. Diaphragm eccentricity. Here we need not define it as -5% once again. Acceleration load is to be applied in the direction U1, and this is the function name in which we have defined the response spectrum function. Now the scale factor value will be equal to I into G by 2R. Impedance factor is unity, G is 9.81 meter per second square. A response direction factor is equal to 5. So 2R becomes 10. So we divide it by 10. If we want to choose a different modal damping, then we can choose that. Use add copy of load case, and this time change its name to spec Y and change the direction to U2. U2 means it is in Y direction, and press OK. Now is the time to save the model, so we use tool button to save it. Now we are ready to run the analysis. However, please take note that from this analysis we will not be able to immediately glean the results for the story shears coming up. And since we need to match the dynamic base shears with the static base shears so that the quota requirements are fulfilled. So we first need to define the mechanism to extract these story shears. For doing that, we use 3D, choose perspective and use rotate 3D view. We are now going to define the groups to define section cuts. Section cuts are used to compute the total forces developing at a particular defined section cut imaginary plane. and only those modeling components are selected whose forces are to be summed together. So in this case, we don't want to use area objects, so use set display option, areas not in view. Only the joints and the column should be available to us so that we could define groups and the corresponding section cuts neatly. Next, we use select menu, properties, frame sections, and we select the beams. And next, we use view menu and choose remove selection from view. And we need to select the columns and joints only on one side of the section cut plane. So we draw a window cutting columns, and window is drawn from right to left, and we select joints by drawing a window but from left to right, and we assign it a group. All that takes time, but it is very rewarding in the sense. Now with patience, keep on defining. Again use assign menu, assign to group, define a group name, select the defined group name and apply. Well, the definition of groups is over, and next we use define menu, section cuts. We define a section cut by selecting a group. Defining next. Keep on defining till all groups have been included. We are now ready to run the analysis, but before we run the analysis, we need to specify the mass source. That is done through define menu, mass source. Choose the option of specified load patterns, and in that self mass is automatically included through the dead loads. Press OK. Now use analyze menu, set load cases to run and press the button run now. Now program runs the model and program shows the deflected shape. We will be choosing. Now use display menu, show tables, structure output, section cut forces, and select the load cases for which we want the output. Press OK. Now we find that the earthquake forces computed from static analysis and dynamic analysis are very different. But that is expected because in the dynamic analysis, the time periods are generally much longer than what the code prescribed time period formulas mention. So what we need to do to match the dynamic and static base shears, simply multiply the scale factor by the ratio of static base shear to dynamic base shear. So we will do that. Unlock the model and use define menu. Load cases, spectrum, use modify show load case and multiply it by the ratio of static to dynamic base shears. Run the model again. Use display menu, show tables, select load cases, now we notice that the static earthquake forces and dynamic earthquake forces are very close. Now we can run the design. We can use design menu, concrete frame design, preferences. In the preference option, we chose Indian code and the item number 7. Choose this P delta flag to no, since we have not yet done any P delta analysis. That's okay. Now do the design. In SAP 2000, once a specific design code is chosen, program automatically generates all design combinations on its own. If we change it to ACI, then program is generated for ACI code. Now see the results by zooming in. Change the unit set to kilonewton and mm. If we right click on the beam, then program shows the details of computed steel at a specific design station. If we choose a column, then by right clicking, we can find the details of the column design, and we can notice that program is computing effective length factors based on the Woods charts given in IS 456. If we don't want to use Woods charts, then we must do a second order P delta analysis as required by the Indian code. We will show you how the P delta case is generated. Unlock the model and use define menu, load cases, and define a new load case with name as p delta. Choose the analysis type as nonlinear. Check the radio button for including geometric nonlinear parameters due to p delta effects. Now add a load combination to estimate the loads which are likely to remain present when later loads are applied. We are not exactly very much interested in doing this kind of combination analysis. Rather, we are only interested in extracting the stiffness from the speed delta analysis to include the effect of axial loads on stiffness. Take a note that design codes recommend to reduce the flexural stiffness of beams, columns, walls, slabs when we are doing a p delta analysis. So how do we activate it here? First of all, we use set display option and we notice that areas are not in view. Next, we use select menu, select and select properties for the beam, and we use assign menu, frame, property modifiers, and we change the flexural stiffness of beams by specifying the property modifier. Next, we select the columns and we specify another set of property modifiers to reduce the flexural stiffness of columns. After that, we need to specify in the load cases that the stiffness which is to be used is the stiffness available at the end of nonlinear p delta analysis. So we choose define menu, load cases. We simply alter the stiffness to use. Next, we define a new load case, and this time we choose it of load case type model and we use eigenvectors, but stiffness we want to use is the stiffness at the end of nonlinear p delta analysis, and we rename it. The purpose of doing a separate p delta analysis for modal cases just to see how much the presence of axial loads and reduction in stiffness factors is affecting the modes and mode shapes. Next, in the response spectrum case, we tell to the program that use modes at the end of p delta analysis. And that's all we need to do for including the effect of p delta analysis. Now we use analyze menu, set load cases to run. Now you have noticed that we are having two modal cases. SAP allows you to do multiple modal analysis with great ease. Run the design again. Many among you might have understood by this time that when we reduce the stiffness, then time periods will get elongated. And the dynamic base shear would be different in this case from the previous one. So we must also match the dynamic base shear with static base shear. Although we are not doing it here because our purpose is to show you how the presence of P delta analysis affects the column design. Right click on the column. Okay, it has not changed. We need to do one more thing. So we need to change the P delta flag in the design preferences. We chose design menu, concrete frame design preferences, and we change it to yes, because we have already done it, and that's why we are saying that P delta analysis has been done. Now run design. Now design is over. We notice that the effective length factor has been taken as unity. So now we are having very clear system of including or excluding P delta analysis in SAP2000. If we are not including it, then program would be computing effective length factors based on the wood charts. But if we are including it, then program will neglect the wood charts and program will assume the effective length factor equal to unity. So this is very simple. Next, we will show you how to see the results like bending moment, shear forces, and deflected shapes as well as joint reactions. So once the analysis has been done, then use display menu, show forces, use joints, press apply. We can notice that program is showing the joint reactions for the chosen joint. In the same way, if we want to see the deflected shape for a specific case, then we can do that. This is the modal analysis with full mechanical stiffness, not affected by the presence of axial loads. And here we take note that the fundamental period is 1.6 per seconds. So we are interested in knowing what is the new time period at the end of nonlinear P delta analysis case. So we chose modal PD and we notice that the time period has increased slightly. But that is expected because when the structure is more flexible, then time period will be longer. If we want to see the forces like bending moments, then we can see it easily. Choose a load case or a combination. Choose the force you want to see. We want to see the moments. Press OK. Now bring your cursor close to any beam and right click, and we see that the bending moment, shear force, the deflected shape, as well as the loading applied is shown. We can change it to any load case to review the bending moments and shear forces, the applied loads, as well as deflected shape of the element. Next, we will show you how a particular drawn area object can be divided. Unlock the model, use XY view. Right away we are at the topmost floor. We are going one story below. Use set display option and include areas in the view. If we want to mesh it at the location of these beams, then select the area as well as the lines where we want to mesh it. And we choose edit areas, divide areas, and we choose the option divide area using cookie cut based on selected straight line objects. And we press OK. Now if we use objection toggle, then we see how the program has meshed this area object into 4 smaller segments according to our needs. Next, we will select these area objects and we are changing this particular floor to a flat plate property. So how we do? Select it and use assign menu, area, sections, change its name to flat plate. Choose the thickness but change the material type to M35, and you can choose out of these 6 different properties, we are choosing a thin shell. Press OK. We again choose these areas and we use assign menu, area loads, uniform to frame. We delete the existing load. We can also use the tool button get previous selection on the left hand toolbar to reselect these area objects, and this time from live load we once again delete the existing loads. In the loading we do not find it, and that was our intention. Select these once again and this time use assign menu, area loads. This time choose uniform shell, and this load will be having only the finishing loads and the ceiling plaster load, because the cell plate would be activated automatically. So we are using 2.5 kilonewton per square meter. Again use previous selection to reselect the drawn areas and change the load pattern to live and change it to 3 kilonewton per square meter. Next, we select these internal beams, as we are not interested in keeping these. Peripheral beams we will have press delete button to delete this. If we want to see the model which would be coming out of this particular assignment of this non-type area object to shell type property, then please take a note that we have not yet changed any meshing pattern for these areas. So we reselect the areas and use assign menu, area, automatic area mesh, and we choose the area meshing based on the automatic mesh size as 1 meter by 1 meter. If you want to see the analysis mesh, then again use set display option. And we can notice that this is the kind of mesh we want to have. The last thing we want to add here is fascia wall on grid B, which is 4 meter wide. So one simple way of doing this is use draw a special joint and draw it go to the next floor and do it. That's enough. And now we use YZ plane and we come to grid number B. Select all columns and delete these. Define a new section property with name as wall, 250 mm thick. Change the material. Now use draw rectangular area and change the property to wall. Next, select the area object which is modeling the drawn wall and use edit, replicate, and replicate it in -z direction and do it twice. Next, we want to manually mesh these walls. So we choose edit, select the base joints and specify the base nodes of the wall with restraints as shown. However, you can notice that the beam is crossing over the wall completely. We use reshaping tool located on the left hand drawing toolbar and click on the beam object and drag it and can grab the handle. Finally, we will be defining the groups for extracting the wall forces and the section cuts so that you get a very good idea how to extract the wall forces from SAP2000. Select walls and the joints and use assign menu. Define a new group with name as W1. Repeat the same exercise for remaining stories. We can check the area and we find that this element is already in the defined group. Next, use define menu, section cuts. Give its name as W1 and choose the group and use design or analysis forces. Having defined these section cuts for walls, we are now ready to run the analysis. Next, use display menu, show tables, and choose the structure output, the section cut forces. Choose only two later load cases. Now we notice that the bending moments as well as the axial forces and shear forces resisted by the walls. So you notice that SAP2000 is extremely easy to use, and you can also use the define menu and generalized displacements to estimate the base rotation of the wall. Although we are not showing it here, as this is a subject matter of some other video. To conclude, we find that SAP2000 offers very wide variety of analysis options. It is very simple and easy to use in one seamlessly integrated. graphical interface. This concludes this video.